Have you ever wondered why you can remember your first day of school, a childhood vacation, or a favorite toy, but not a single moment from being a baby? Every human being spends thousands of hours experiencing the world during infancy, yet those experiences seem to vanish. This mystery is known as infantile amnesia, the phenomenon in which our earliest years remain inaccessible to conscious memory. In this presentation, we'll explore what scientists have discovered about the developing brain and why our first experiences disappear from recall despite shaping who we become. Infantile amnesia refers to the near complete absence of autobiographical memories from the first years of life. The phenomenon was first described by Sigmund Freud, but modern neuroscience has replaced his explanations with biological ones. Importantly, this memory gap appears across cultures, languages, and societies, suggesting it is a universal feature of human development. Most adults cannot reliably remember events from before the age of 3, creating a fascinating question, hide in skies. If we lived through those experiences, where did the memories go? For many years, scientists believed babies simply could not form lasting memories because their brains were too immature. Today, evidence suggests a different story. Research shows that infants can learn patterns, recognize faces, and remember experiences. The issue may not be that memories were never recorded, but that they cannot later be retrieved. Recent studies have found links between hippocampal activity in infants and later recognition abilities. In other words, the brain may be storing information, but the adult mind struggles to access it. At the center of memory formation lies the hippocampus, a structure present from birth and essential for creating episodic memories. During infancy, this region is highly active, helping encode new experiences. However, the hippocampus is still developing and undergoing rapid change. Scientists increasingly believe the challenge is not recording events, but maintaining stable access to them over time. Memories may be written into the brain, yet the pathways needed to retrieve them later are still under construction. One of the most compelling explanations involves neurogenesis, the creation of new neurons. Babies produce neurons at extraordinary rates as their brains rapidly grow and adapt. This process makes infants remarkable learners, absorbing language, faces, and environmental patterns with incredible speed. Yet there is a trade-off. As new neurons are added, older neural connections can be disrupted or reorganized. The very mechanism that powers rapid learning may also overwrite or weaken the circuits that preserve early autobiographical memories. Another theory focuses on language. Infants experience the world before they possess words to describe it. Adult memories are often organized as stories, complete with descriptions, concepts, and narratives. Baby memories, however, are encoded without language. When adults attempt to retrieve those experiences, they may lack the verbal framework needed to reconstruct them. The memories could still exist in some form, but without the language-based structure that later memory retrieval depends upon. Memory is not only about events, it is also about identity. Autobiographical memory requires a sense of self, a feeling that experiences happen to me. Developmental research suggests this self-concept begins to emerge between roughly 18 and 24 months of age. Before that, experiences occur, but there may be no stable personal narrative connecting them. Without a developed sense of self, the brain may struggle to organize experiences into the kind of memories adults can consciously revisit. The prefrontal cortex, responsible for organization, planning, and higher-level thinking, is one of the last brain regions to fully mature. This area helps structure memories, connect them to context, and integrate them into long-term narratives. During infancy, these systems are still developing. As a result, memories may be stored in fragmented ways that are difficult to access later. The brain has not yet built the sophisticated retrieval architecture that adult memory relies on. Scientists generally group explanations for infantile amnesia into three major categories. First, the storage failure theory argues that early memories were never preserved in a stable form. Second, the retrieval failure theory proposes that memories still exist but cannot be accessed. Third, the neurogenesis overwrite theory suggests rapid brain growth disrupts earlier memory traces. Current evidence increasingly favors a combination of retrieval difficulties and neurogenesis rather than complete storage failure alone. Although we cannot consciously remember infancy, those years profoundly influence our lives. Early experiences help shape emotional bonds, personality tendencies, learning patterns, and even responses to stress. The memories may be inaccessible, but their effects remain embedded within the brain. In a sense, we are partly defined by experiences we can never consciously recall. Infantile amnesia reminds us that memory is not simply about what we remember. It is also about the hidden foundations that quietly shape who we become.